Hey, Jody here with weldingtipsandtricks.com. This is part 4 of MIG Welding Basics. Today we're talking about lack of fusion and a tip to avoid lack of fusion. Also, a MIG welding technique I almost never use and why. And somewhere in this video is going to be a few words about the ALS Ice Bucket Challenge. Let's go. This is a technique that I almost never use, and the reason is because it doesn't keep the arc on the leading edge of the puddle. It backs into the puddle. It takes the arc up to the front of the puddle on the toes of the weld, but it doesn't take the arc down into the root of the weld. And so the only time that I use this technique pretty much is just when there's a gap I need to fill in and I don't have to worry about the root because it gets hot because there's a gap there. To exaggerate what goes on, I set the machine just a little bit lower than what's recommended for 1/4 inch steel. Just you can see down in the root of the joint there, the arc is not going there and the metal's not biting in there either. And right there's a little notch, and that's called lack of fusion, also known as LOF, and it's not a good situation. Even if you run the machine hot, you risk lack of fusion when you use a technique that doesn't keep the arc in the leading edge of the puddle. What I prefer to do is something like this or some other technique that takes the arc in the front of the puddle, basically tracing the front of the puddle so that the arc provides the heat at the leading edge of the puddle where fusion's taken place. Something like this. Now, this is just one technique that does it. It doesn't typically make for the best looking weld, but it's a very effective technique as far as just getting penetration into the root of the joint. So after welding both sides of this joint, one way and one the other, I sectioned and started off with a 100 grit sanding disc and then used some Scotch-Brite pads, a red and then a blue, and that gets me to a fine enough polish to let the etch work and reveal the nugget, and we can see exactly how much penetration we got or didn't get. Now I just use naval jelly made by Loctite to etch carbon steel. It takes a minute, but it's very effective if you got a fine enough polish on it. You take a little acid brush and just work it, or a Q-tip works. And you can see it reveals the weld nugget there. It takes about 30 seconds to a minute to get the contrast. But here's a close-up of that. You can see the technique where I didn't go into the root of the joint like this. You can see it not going into the root of the joint. You can see it not making it down. There's a little notch. And when you think there's a notch and you think you're not getting into the root of the joint, you're probably not, especially with short circuit MIG. So this is, again, technique that I would only use when I have a gap I'm trying to fill up. And you can see what it does, just like it looked in the puddle. You got that little notch in the root that just laid in there. The metal just rolled in there, didn't bite, didn't penetrate, didn't fuse. And so now I've got a much smaller weld there, much smaller cross section of weld than I would have if I had a good penetration. Let's contrast that with this technique. This could actually, it would be a lot better if it was a little hotter, but it definitely appears that it's getting into the root of the joint much better than the previous technique. And you can see that tiny little speck there in the root of the joint is what could actually fail you on some fillet weld macro tests, but it's much better than this situation, and that is about 125 thousandths of actual throat size there, and this is about 195 thousandths of actual throat size. So the actual size of the weld, even though the appearance of the welds from the surface is about the same, big difference in the strength and size of those two welds. Now turning it up, something more appropriate, this is 333 inches per minute, 20.5 volts. Using that technique, just that kind of plays the arc to the front of the puddle but backs up in it a little bit, and then also contrast that with just a straight up drag technique, pulling the puddle, just staying on the front of the puddle. We'll etch those two joints using those two different techniques, and we'll see what those look like. Being able to etch welds shortly after you weld them is a very educational exercise. That's the one where I just straight up drug it just like this, keeping the arc on the front of the puddle and keeping a short stick out, which is also very important to do. We'll talk about that in a future series, the importance of using the right stick out. And again, that's what it yielded, a nice little nugget right down into the root of the joint. And the one on the right hand side, Not quite as good. You got a little questionable area. If this was a fillet weld macro etch test, they would draw imaginary lines like along the planes of each member, something like this, and then that would determine if that was actual lack of fusion. And it looks like it kind of is, but it's pretty minimal. Because this is supposed to be about raising awareness and raising money, I'm going to make my donation and dump some ice water on my head. But let's talk about Lou Gehrig's disease for a minute, because the face that they put with the disease, Lou Gehrig, was also called the Iron Horse. He was a rock-solid player who never missed a game and beloved by the fans. And on that day when he gave his farewell speech back in July 1939, here's what he said. "I consider myself the luckiest man on the face of the earth." He was just given his diagnosis, and yet he considered himself the luckiest man on the face of the earth. Think about that for just a minute. If attitude could have beat ALS, Lou Gehrig certainly would have done it, but it doesn't. So they need money for research. I'm going to make my donation. I nominate Brent Williams, Jimmy DiResta, and Mike Rowe. Okay, that about wraps it up for this week. I just learned that Jimmy DiResta did accept the challenge. So if you're not subscribed to his YouTube channel, he makes stuff, all kinds of stuff, woodworking, a little bit of welding here and there. Jimmy DiResta, one word. And the takeaway really is always use a technique on anything like thicker than 1/8 of an inch. Always use a technique that keeps that arc in the front of the puddle, in the leading edge of the puddle. That arc, right where that wire meets the puddle, that's what creates the heat. And if you're always back in the back side of the puddle, you run the risk of just rolling that puddle over instead of getting adequate fusion. So that's where you get cold lap and lack of fusion. It also matters on how hot you have the machine set. So I like that stack of dimes look and everything, but first things first, you got to get adequate fusion. Then you can work on a technique that makes a stack of dimes look, because if you got that lack of fusion underneath, it's a house of cards.